Gotta wait for YouTube. Okay, while that happens, okay, I think this is my first ever compiler build in, well, actually in any language. I'm gonna be building it in Zig, and I thought, why not use the only book on compiler that I own, this one. Quite excited actually. Went back and built the parser in Zig so that I could do this. Okay. Hang on. Yeah, I forgot about this. Let's close that. Okay, we're good to go. It's weird, like YouTube gives me a new chat every time. No, don't go to the channel. Maybe I'm doing it wrong. It's this one. Let me check. Testing YouTube chat. No, it isn't. Doesn't even show up. Okay. Guess I gotta do this again. Oh, okay, I see it now. Okay. Jeez. That was like 2 minutes. Okay, let's go. I mean, there's no hurry because something's wrong with my voice. Excuse me. Yeah, well, I'm saying there's no need to hurry because I don't know what I'm doing. This is day 1, so I'm quite excited actually. Let's see what we will have built at some point. Compilers, yeah, that's good. Virtual and real machines. Okay, this is just the intro. That's a good question. What are we doing? Adding to the stack. Interesting. Oh, jeez. That seems familiar. Infix expressions. Booleans. 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 Comparison operator. Yeah. We have all of this. Compiling conditionals. Okay, nice. This actually looks quite interesting. Taking time. Okay. I guess we can get started. Acknowledgements. Okay. Started this book 1 month after my daughter was born. I finished shortly after her first birthday. Or in other words, this book wouldn't exist without the help of my wife. While our baby grew into the wonderful girl she is now and rightfully demanded the attention she deserves, my wife always created time and room for me to write. Couldn't have written the book without her steady support and unwavering faith in me. Thank you. Thank you, Thorsten's wife, so that he could write this book. Thanks to Christian for supporting me from the start again with an open ear and encouragement. Thanks to Ricardo for providing invaluable in-depth feedback and expertise. Thanks to Yoji for his diligence and attention to detail. Thanks to all the other beta readers for helping to make this book better. It's sweet. I like it. Short and sweet. Okay. How long is the introduction? Okay, since we have just read it. I have read this before, like a long time ago. There's something about a lost chapter. You can look it up. It's pretty cool. But yeah, okay. Let's go to evolving monkey, a human. The past and the present. In writing an interpreter in Go, we built an interpreter for the programming language Monkey. Monkey was invented with one purpose in mind: to be built from scratch. in writing an interpreter in Go and by its readers. Okay, I've totally squandered that. Whoa. The playback is so far behind. Kinda strange. Kinda strange, not gonna lie. Well, I guess waiting ain't gonna make it any better. Well, anywho. In writing an interpreter in Go, we built an interpreter for the programming language Monkey. Monkey was invented with one purpose in mind. I read this already. Oh, this is the one I squandered. Fully official implementation is contained in writing. Oh, it's contained in writing an interpreter in Go. It's contained there. Although many unofficial ones built by readers in a variety of languages are floating around the internet. Hey, just like my one. There you go. He gave me a shout out. Thanks. Thanks. In case you forgot what Monkey looks like, no. Just finished building it yesterday. Well, not all of it. Doesn't do any evaluation. To be fair, I think evaluation is not hard. Excuse me. On an interpreter. Because I can just ask Zig to do the thing. Once I know what the thing is. Which is the hard part. Getting to know the thing. Okay, moving on. Yeah. Looks familiar. Can do all of this. Can't do this at the... Oh. What the fuck is this? Not sure. Whoa. Where did this come from? Guess I missed a few chapters. Certainly don't have arrays. Although wouldn't be... Okay, it's caught up. The stream. Maybe. I don't know. Oh no, it's still too far. It's like weirdly too far behind. Don't like it. Okay. Yeah, I guess to implement this shouldn't be too hard. Start with the bracket and stop at the other bracket, and you parse all the expressions in between. Oh yeah, and you split by commas. This looks like a map. I was gonna say struct, but it looks like a map or a dictionary. My eyes. What the fuck? Can't do that either. But if it was... I think the parsing bit, not too hard again. Again, start at this bracket. Ooh, but it can be a block as well. Interesting. Okay, well, the one I wrote can't do this. Let's just say that. And if I go to the contents, past, present, future. I didn't see executing jumps. Okay, there is. Well, we can just, I might do the array. I might go back and do the array. The hash, I mean, maybe, I don't know. Okay. Yeah. Okay, so this is the past. My past looks like a basic version of this past. Yep, can do this. Can't do this. Yeah. Yeah, definitely can't do that. The array. All the other stuff inside can. What is this? Map. Oh, it's a function. Okay. 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 Translate it into a list of features. Can do. Yeah. Booleans, yes. Strings. I'd like to say yes. Yeah. Can. Arrays, no. Hashes, no. Prefix, yeah. Infix, yes. Conditionals, yes. Ooh, yeah, I think local binding. I haven't done evaluation, so. But I guess, oh yeah, I parse block statements. So I guess, yeah. First class functions. I mean, there's only one type of functions, so I would say it is pretty first class. Even though I wrote it myself. Return statements. Yeah. Closures. Oh, there's no evaluation, so I don't know. But can do. So about 70% story of my life. Yep. Build an Elixir that turns strings into the REPL into tokens. The Elixir is defined in the Elixir package, and the tokens it generates can be found in the token package. Yep. After that, we built the parser. That's as far as I got. A top-down recursive descent parser that turns the tokens into an AST. The nodes of the AST are defined in the AST, and the parser can be found in the parser package. Excuse me. After it went through the parser, a monkey program is then represented. This is where it gets a bit... See, the only reason I didn't build a parser is because I tried reading this book. Well, I thought I could just start with the compiler, but turns out you need the parser. So I'm hoping that is still true, even though the book hasn't changed. Or that I read it correctly. Well, if not, whoa, that was a bit loud. Why was it so loud? Okay, yeah, well, if not, we go back and then build a evaluation. No biggie. With that, ooh, where did I? Yeah. After it went through the parser, then represented the memory as a tree, and next step is to evaluate it. Yep, done that bit. In order to do that, we built an evaluator. That's another name for eval. Eval recursively walks down the AST. I think once you have the parser, evaluation is not that bad. Using the object system, we defined in the object package to produce values. Excuse me. It would, for example, why did it need to be excused? Too late. It would, for example, turn an AST node representing that into an object like that. Yeah. With that, the lifecycle is complete and the code would be printed to the REPL. This chain of transformations from strings to tokens, from tokens to a tree, and from a tree to object is visible. Yeah, I think mine should look pretty similar, I would say. Yeah, parser, parse program. Just don't have this bit. I could print the AST. Yeah. Okay. Macro system for monkey. I have seen this chapter or heard about it or googled it. Not sure. But I like the idea how you can program monkey. Well, how you can program a language with language. Fascinating. In this book, though, the lost chapter and its macro system won't make an appearance. It's as if the lost chapter was never found. And we're back at the end of writing an interpreter in Go. That's good, though, because we did a great job implementing our interpreter. I guess we did. Monkey worked exactly like we wanted it to, and its implementation was easy to understand and to extend. Jeez. My throat is itchy. So one question naturally arises at the beginning of this book. Why not leave monkey as is? Because we're here to learn, and monkey still has a lot to teach us. Monkey see, monkey do. One of the goals of writing and excuse me. Jeez. Don't know what I ate yesterday. Okay, so one of the goals of writing that was more about the implementation of the programming languages we're working with on a daily basis, and we did. A lot of these real world languages did start out with implementation really similar to what we've done so far. And what we learned by building Monkey helps to understand fundamentals and origins. But languages grow and mature. In the face of production workloads and increased demands, the performance and language features, the implementation and architecture of a language often change. Production. Oh, I don't think compilers ever seen daylight. One side effects of these changes it loses is that the implementation loses its similarity to Monkey, which wasn't built with performance and production usage in mind at all. No, it wasn't. Okay, this gap between fully grown languages and the one we wrote is the biggest drawback. Fair enough. Its architecture is as removed from the architecture of actual real world languages as a soapbox car is from a Formula One car. It has 4 wheels and a seat, sure. It can help to learn the fundamentals of steering. But the fact that it's missing an engine is hard to ignore. Yes, indeed. In this book, we're going to reduce this gap between Monkey and real languages. I was gonna say like Python. Just kidding. I like Python. We'll put something real under the hood of our Monkey soapbox car. I'm guessing it's talking about the compiler. I'm going to turn tree walking on the fly interpreter into a bytecode compiler and a virtual machine that executes the bytecode. Ooh, sounds exciting. Nice. I mean, just the idea of it, I like. It's not only immensely fun to build, but also one of the most common architectures. I'm tired of saying that word. It's not the easiest word either. Inter, interpret, It's the last. It's the in the end. It gets me. Ruby, Lua, Python, Perl, Gil. Who's Gil? Never heard of that one. Different JavaScript implementations and many more programming languages are built this way. Even the mighty JVM interprets bytecode. Bytecode compilers and virtual machines. I'm a bit distracted. I want to know, what is this GIL programming language? GNU GIL. GNU, ubiquitous intelligent language for extensions. First version 1993. That's old as me. GIL scheme. GWEAL offers libgweal, which allows language to be embedded in other programs. Interesting. And integrated closely through the C language program. There maybe an example of GWEAL? GWEAL. Gambit. Is that like a chess language? I just want to see what it looks like. I like the artwork. Hello world. There we go. It looks like Python with brackets. Or like some functional programs. Don't know which ones. Because I don't think I've ever written one. Striffy 64. Test begin, test equal, test hello. Isn't this the same? Define module hello. Define public hi. Lambda hello world. What's a lambda? It's like a function. Is that why is maybe Let's see, like one more method. Lambda star is in a lambda that returns no, not sure. Greeting prefix, greeting suffix, find default addressee world, find public hi. Guess that's the function. What's this lambda? Test. I mean, looks pretty cool. Okay. It's good intro to Guild. Guild with an E. Guild. I guess. Okay, where was I? Here, maybe. Besides providing a new layer of abstraction, the bytecode that's passed from the compiler to the virtual machine that makes the system more modular. The main appeal of this architecture lies in its performance. Bytecode interpreters are fast. Okay, let's go. I like fast. Want numbers? Okay. Oh, okay. I was like, don't want numbers. It means stats. At the end of the book, we'll have an implementation that's 3 times faster than its predecessor. Ah, okay, gotcha. It was pretty slow. I do remember. I think if I look at my GitHub and I think, what did I call it? Go enter. How old is this? 2 years ago. Jeez, it's a long time ago. Oh, I did support string. Interesting. Yeah. It's pretty similar to what Thorsten's done. Nothing fancy. Boolean. I do have, but I think this is more complete. Function params, literal. Yeah, So I don't have this. I guess not to. Prefix expression. I didn't think of function calls. But yeah, I would need call arguments. Yeah, I need this method. And this parser. Guess the rest of it is the same. Next token, blah blah blah. Yeah, it's about missing 3 small methods. Call arguments. Yeah. And may have a look at the eval. Yeah. And oh, okay. I have an env. Guess and yeah. That's everything that's global. Eval. Yes. Program, eval program. Mm-hmm. Apply function. I think the built-in was written in Go, if I remember correctly. Yeah, it is. Len. Fit string. Okay, yeah. It's, I think it's, yeah, just called the length method. Okay. Hopefully. Don't need to. I don't think so. Excuse me. Ready to write some code? Like, yes, yes, yes. Let's get the practicalities out of the way so we can start. Okay. Like the first one, tiny number of instructions. Let's read start to finish. Follow along by reading. Type in, yeah. These books are practical. They're about writing code and building something. If you want theory, you're better off by choosing one of the canonical textbooks. That's not to say try my best to guide and explain everything, what everything is, and how the pieces fit together. It just won't be as academic as a textbook on compilers. It's okay, no very academic myself. That's how I intend it to be. This book, just like the predecessor, comes with a folder called code. Okay. Am I leaking that URL? Hopefully no. I mean, it's just the code. There's plenty of it on the internet. In this folder, you'll find subfolders. Yep. Helpful. 0 is what differentiates the book from the first one. We don't start with a clean slate, but build upon the code base of the previous book. It doesn't correspond to a chapter of this book, but contains the complete code base as we left it at the end of the previous one. That also means it doesn't include the macro system from the lost chapter. The lost. On my back. Oh. But if you're a fan of the macros, it shouldn't be too hard to keep the macro expansion step around. I mean, I'm not too eager to start writing the code because I am afraid I'm missing a few things. Let's just find out. I try to show most of it, but sometimes I'll only refer to something located in the code base without actually showing it. Why? Most of the time, because it's a repetition of something we've seen before, and showing it would take too much space. And I think this is a bigger book compared to the previous one. I know because I printed it like a madman. So got the printed version. Talk about the tools because I have some good news. You don't need many. Installation of Go will be using Zig. Which version of Go will be using Zig? 0.14. I think the current one, the current release one. At least that one for Go, because that's what I'm using at the time of writing. Because we'll use a tiny number of features that were only introduced in Go 1.8 and 1.9. Okay. If you're not using Go greater than 1.13, then I'm gonna sorry. Then I also recommend using the dir env. to work with the code folder that can change the environment of your shell according to an envrc file. Excuse me. Whenever you cd into a folder that checks whether the code contains an envrc, then executes it. Each subfolder in code contains... Okay, I'm just gonna skip this. Yeah, because not using Go. Ooh, what's this? Compiler, virtual machine. Okay, so this is where my assumption comes in. When I saw this or read this part before, long before, my understanding was you only need the parsed code, then you send that to the compiler. For most programmers, the word compilers has an intimidating ring to it. Yes, it does. It does for me. And even if you're not intimidated by it, can't deny that compilers and what they do is surrounded by an air of mystery and amazement. Oh, I guess I should have said amazement louder. They produce machine codes seemingly nobody mortal can read or write. They do magic optimization that somehow make the code run faster. It can take a long time to run, minutes or even tens of minutes. Hence the meme. If the rumors are true, they sometimes even run for hours. What rumors? Oh yeah, I know. If it takes that long, what they're doing must be extraordinary. I guess so. Or it could also be, Speaking of rumors, well, what was that show? Oh yeah, Top Gear. Speaking of rumors, it reminds me of when they introduced Stig in every episode. It said that compilers are incredibly huge and incredibly complex. In fact, they can often be listed among the most complex software projects to ever exist. And the claims backed up by numbers. Here's a taste. The LLVM and Clang projects currently consist of around 3 million lines of code. I think all of my GitHub repositories maybe have like 100k lines of code, maybe 200. A million line. I've never seen a million lines of code. I'm a basic programmer. Million sounds like a lot of code. The GNU Compiler Collection, GCC. Oh, is that what it stood for? It's even bigger. 15 million lines of code. 200 billion. It's a lot of code. 15 million lines. Jesus. I wonder how many people it took to write that many lines of code. Guess quite a lot, or not many, I don't know. That is a lot of code. There are not a lot of people that look at these numbers. Yeah, look at these numbers, open their text editor and say, you know what, let's build one. I wouldn't say that, but maybe we can build a small one. Well, I mean, I am here trying to build it, so I guess already said it. What's that called? The Valley of Optimism. Yeah, I'm still in that valley. So yeah, let's build one. They certainly do not evoke the sense that one could write a compiler in an afternoon. Well, I definitely don't think I'd be able to do it in an afternoon. Okay. Virtual machines 2 are largely understood to be mystical creatures roaming through the dark layers of software development, seldom seen in the light and even less understood. They too attract their fair share of rumors and speculations. Some say that's the Top Gear light. Was it some say, or was it something else? Can't remember. Some say that virtual machines have something to do with compilers. While others insist that they're programming. It's like programmer. Is that what it means? No. Is that what it comes from? Now I have to look it up. Where does the word programmer come from? Hey Toby, how you doing? Hello. Program. Okay. So not programmer. Another group claims that virtual machines allow them to run an operating system inside an operating system. Doesn't help that all of it is true. So what am I working on? I just finished working on the parser for my interpreter yesterday. And I built a parser so I could work on the compiler. The first time I'll be ever doing it. Yeah, so I'm building a compiler with Zig. But here, okay, it doesn't help that all of it is true. I'm just reading the introduction of the book. It's called Writing a Compiler in Go. I'll be writing in Zig. Um, bytecode. Yeah, that's what it says in the book. People keep asking me that. It's only today I found out what that question means. Yeah. Have you built a compiler before? Yeah, I know. I mean, that's how fresh I am to this compiling business. That's as much as I know. Yeah. I mean, you can tell by the answer how much I know. I just recently made a transpiler into Lua. Transpiler into Lua. Kinda like TypeScript for JavaScript. I made a transpiler into Lua. Not sure what that means. Okay. Ooh, okay, well, the compiler that you built, what did you compile into? I added types and got rid of the base one, indexing, and also a nicer syntax. I guess that's one way to get what you want out of a language. Do you was it like just for fun, or do you actively use it? Hey, where was I? Well, yeah, I was getting roasted by Toby here for my vague as fuck answer. Okay, when I made a compiler, it compiled into my custom assembly language that assembled into my custom VM. Because I love writing simple 80s style computer VMs. Okay. Well, you know, Toby, your answer is quite vague too. But maybe because compiled into my custom. Okay. Well, okay, I guess your answer is much better. Okay. I give you that. I don't know how you write your own assembly language. That's pretty cool, Toby. I also did one that compiles into QBE. No idea what that means. That will count. What do you mean? The compiler counts? Compiles into QBE. Maybe I've heard that before. Maybe not. No idea. But sounds pretty awesome. maybe by the end of the book, I might be able to give you a better answer. That link looks a bit dodgy, Toby. Sure it's not, but I will check it out. But here's the thing. At their core, compilers and virtual machines are ideas, patents. Just like it's the official QBE site. Okay, we'll check it out. Site. It can have multiple implementations. I guess he's talking about QBE. Ranging from tiny to massive. Toby, how long did it take you to build the compiler? I just want to get an idea of what I'm getting myself into. Okay. Well, I got time. Months doesn't sound bad. Well, I mean... it's not very reassuring either. And... yeah. Did you use a book or you just made it up as you went along? On my own, I don't like going by a guide. Takes the fun out of it. Yeah, okay, makes sense. Sure. I mean, yeah. All I know about compilers is that you get bytecode at the end. So I might need some help. By the way, my answer earlier wasn't a reflection of you. It was more a reflection of me. That was like the best answer I could give. That was quite funny. Sure, it's not a small task to build a compiler for a virtual machine. Some say it takes months, but it's also not as insurmountable as reputation suggests. And once, yeah, I mean, and I was like, I can't go wrong, can I? Seemed like a all-encompassing answer. And once we have a better understanding of these core ideas, what a compiler and a virtual machine essentially are, you'll see that you can in fact build a compiler in an afternoon. In an afternoon, probably no May. The first step towards... well, I have a question, Toby, if you're still here. When you decided, let's say at some point you were going to build a compiler, how did you know where to start? Or like, where did you start? What was step 0 in your transpiled language? Well, it's like saying, what kind of tea are you drinking? I'm drinking tea made from water. I mean, that's not what makes it tea. I hope you know. It's the tea. Well, I mean, I see what you mean. Okay, you started with tokenizing. So, did you build, let's say, part of an interpreter? Like, tokenizing sounds like it could be part of an interpreter. Just for context, because when I was building the interpreter, you build Alexa, at least from the book, Alexa and a parser. Bytecode doesn't make an executable. Bytecode doesn't make an executable. Okay. Okay, makes sense. That's pretty cool that you sort of figured out as you went along. I'm either too lazy or I just suck at it. Same as water doesn't make tea. Okay, Toby, you've made your point. I knew the theory behind it. Yeah, there we go. Okay, makes sense. Same as water doesn't make tea. Yeah, it doesn't. It's the tea. It's all good. It's all good. Well, how did you know the theory behind it? No, it's not something you stumble over. Well, okay, I'm guessing you read it somewhere. But compilers. I'd ask you to name a compiler. Probably, and without missing a beat, give me a name. Give me a name like GCC. I honestly don't remember the exact place where I learned all of it. I've been studying everything about computers for some years now. Okay, so it's like something you've accumulated over time. How, let's say, the transpiler I did just now only took about a week, but it's scuffed as hell. I don't know if it's a week long enough to build a transpiler. So, did you I don't even know how you did that, to be fair. Never. No, I have no idea about transpilers. Okay. Not a proper one, but enough to make a working one. Makes sense. Do you use it? Like, was it just for fun, or you were like, you know what? I can write this language better. And is that why you did it? Excuse me. Okay, it's not finished. You are planning to use it. That's pretty cool. I made it. Okay, now I have to ask, like, I will check it out, by the way. Yeah. If you didn't want to work in Lua, I mean, you don't have to. Why? I have to ask. Did you have to use Lua for something, and it was the only option? So you were like, I'm gonna write a transpiler first. Okay, that makes sense. I mean, I think that's like fucking awesome. Yeah, that's pretty cool, Toby. I would have just like, yeah, that's pretty cool. I do like that. Lua is highly embeddable, so it's at a lot of places. So I've heard. I don't think I've written much Lua. Maybe just enough to, well, not even that. I was gonna say like my config in NeoVim, but I mostly just copy whatever the documentation says. The source is one awful ass 1700 line file. Hey, I like, at least it's in one file, right? I don't really mind the single file thing. I kind of like it. I like big files. That's what she said. Yeah. A lot of people like a lot of files. It makes it quite annoying. I mean, not that bad, to be fair. If you have an LSP, it's fine. Hang on, now I've got to check that awful file. You wrote it in Rust. I've never read or looked at a Rust code, so I don't even know what I'm looking at. Let's go with mass. Source looks promising. Okay, guessing this is it. I've heard that one too. Rust has nice string handling. If you look at the work in progress, standard lib, it has already like 10 files. Okay. don't know what I'm looking at, but it looks promising. Okay, you've got some form of standard out. Would you do the evaluation too with Rust? Or is it just... I don't know what it is. Or... The whole thing is just this one file. I mean, that is pretty cool. You can just like parse all of Lua with just one Rust file. I mean, it's, yeah, it is 1700 lines. It's not bad either. What does the post process do? Made by Toby, of course, one and only. Replace. Don't worry, I'm not judging your code. Wait, you haven't seen my code. It's pretty shit most of the time, I would say. Some of them is not bad. Most of it though, hot pile. Guessing these are like helpers. Remove unused variables. Replace variable names. How come? Do have like a prefix for all the transpiled code methods, functions, variables, or something? Symbol to Lua. These are, I guess, your tokens. Okay, that makes sense. Changes the variable and function names. So the code is shorter. Mm-hmm. Kind of makes sense. Hey Toby, I guess you're everywhere. Get some of these things. Yeah, it's like it's so busy I can't keep up. Like it is, yeah, it's too many to count. Hey, I have more people now than I did before. I guess okay, some of this makes sense because I just wrote the interpreter. If fine. Okay. You know, Toby, I'm terrified to open Discord because I use it for work too, and I don't know what's the last thing I left open. So I'll probably check it after the stream. I don't think my work will be very happy. Me streaming. I mean, not that there's a lot of people here, but still. Mm-hmm. Excuse me. Like, resolve. Let's turn off screen capture for a second. Yeah, but that seems like a lot of work, honestly. I'll take it later. It's not like the message is going anywhere. Resolve indexing chain. What does that mean? That one was made by GPT and later modified like 300 times by me. It's all individual tokens in the expression. I mean, yeah, I wouldn't trust a comment written with an emoji myself. It's like What kind of asshole has time? Like, fucking light bulb. Doesn't even make sense. Okay. Um. I mean, all of this looks pretty cool, Toby. I understand maybe 1%, maybe 5. Where's your refactor? Guessing, what is MAS? Is that how you write ROS file? No, I don't think so. Looks good. I'll give you a star. Maybe you'll catch on. Ah, okay. Makes sense. So that's what, excuse me, that's what you call in your transpile language. Nice. Oh, actually, in that case, should probably have a look at what the end result would look like. Oh, this is okay. I see. Yeah. Got types. Nice. This is string. Got some built-in methods. So I'm guessing you've only got bool. Oh no, you've got num. Okay, converts anything to a num. Okay, nice. Got some built-in too. Built-ins, I should say. That was a good side quest. Thanks to Toby. What was your compiler called, Toby? Okay, that's probably why I skipped it. I looked at the name and I was like, that looks complicated. Yeah, you see, I knew there would be some. Whenever there's more than one underscore, I think it's a sign of complexity. Mass transpiler, no special name. Okay. Oh, okay, so you sort of... No, I'm not even gonna pretend I understand it. I don't. But I think it looks good. Looks complex. A lot of underscores. I mean, I wouldn't know. I would just say, looks good to me. Thread internal thread names of T. Because you did change the index, didn't you? Rookie mistake, Toby. Well, you can fix it now. Yeah, that was my first thought. One indexing of the word. I like that you built a whole transpiler because it pissed you off. Yeah, I mean, if I were to name a compiler, I would say, is LLVM a compiler? LLVM, what is it? It is. Modular Reusable Compiler and Toolchain Technologies. Okay. Clang is an LLVM native. More of an assembler. It's the backbone of most compilers. Hey, I never knew. How I know? In any case, it would most certainly be a compiler for a programming language. Yes, it would. Chances are that it's a compiler that produces executables. Most compilers compile into LLVM, which actually assembles into x86, ARM, etc. Most compilers compile into LLVM. Okay. Today, I'm guessing they do that so they can support multiple, architectures. So they don't have to do it themselves. Makes sense. Smart move. Guess, is that does the Go compiler VM? Okay, there is one. Go plus C plus Python. Okay. I was just curious. Compilers come in all shapes and sizes and compile all kinds of things, not just programming languages, including, regular expressions, database queries, and even HTML templates. I'm pretty sure I use a couple without realizing it. That's because the definition of compiler itself is actually quite loose. Much more so than one would expect. Compiler Regex is how highlighting works. What highlighting? Do you mean? It's like a strange statement. Speaking of vagueness, you know, too much of a beacon of clarity either. Encode the colorful keywords and stuff. I thought that was because of NAST. Because of the, no, with the AST. Or is it just traceable? Compiler is computer software that transforms computer code written in one programming language into another. Compilers are a type of translator that support digital, not NAST, AST. There's a space in between. I don't know if you're trying to be cheeky, but yeah, I meant AST. You know, English and stuff. Well, your transpiler says otherwise, Toby. Compilers are a type of translator that support digital devices, primarily computers. The name compiler is primarily used for programs that translate the source code from high-level programming to a low-level assembly language. What is object code? Object code. Okay, is that it? Computing object core object module is a product of an assembler or compiler. In a general sense, unlinked pieces of code. Oh, like the individual components. No, that deals with structuring of operations, not with how colors are applied. I don't know, Toby. I think you might be wrong there. If I use Treecitter, I think it uses the AST to show colors. Because I have seen the AST. When you use Treecitter, you can see the AST. Compilers are translators. Oh, with object code or machine code to create an executable program. Compilers are that feels uselessly complicated. I guess, but it is a lot faster than using regex. That would be my guess. And yeah, I think definitely faster. Compilers are translators. That's vague. And a compiler that translates, I think, and it's also like less resource intensive compared to using regex, I guess. Do you have files with over 20,000 lines? No, I don't. But I like the fact that if I ever did, I'd be ready, you know? And to be honest, I don't care. I just happen to use TreeSitter with NeoVim. It makes everything looks nice. And this is all the other stuff that comes with it. So there you go. Sounds counterintuitive. And a compiler that translates high-level language to produce executables is just one special type of compiler. I got to read that again. Translates high-level languages to produce executables is just one special type of compiler. Sounds counterintuitive. Doesn't. I have no idea what I just read. Okay, high-level languages produce executables. It's just one special type of compiler. Guess it doesn't sound counterintuitive. I think they're producing executable. Oh, okay, I see what you mean. It's just what a compiler does. That's what GCC does. Hey, thank you, Toby. That was a lot of fun. Thank you for hanging out. You take care, my man. That's what Clang does. That's what the Go compiler does. Shouldn't be the first line of the definition. Okay, shouldn't that be the first line of the definition? How can this be non-essential? I don't know. Damn, how much more reading do I have to do? A lot. I might skim ahead a little bit. Or, I don't know, maybe. I'll carry on for now. I'll read through all of it today. Maybe tomorrow I can start writing some code. Maybe. Oh, we might be reading for a few days by the look of it. Hang on. Where did the stack pointer? I mean, it's fine. Okay. Let's just go through it once. Okay. The solution to this riddle is another one. What's an executable if not a source code in a language the computer can natively understand? Not source code in language, yeah. Hence compiling to native code. Same as compiling to machine code. Yes, really, producing executables is just one variation of translating source code. You see, compilers are, let me this out of the way, because, okay, it's fine. Compilers are translators. I know I read this already. Compilers are fundamentally about translation, because translation is how they implement a programming language. Yeah. Let's take a step back. Programming means giving instructions to a computer. Yes. We write instructions in languages the computer can understand. There's no point using any other language. Now, implementing a programming language means making the computer understand it. Right. Yeah. There are two ways to do that. Either, interpret the language on the fly or translate it to another language one the computer understands. So compilation is kind of like translation. It's like humans and helping a friend understand language she doesn't speak. We can either listen, translate in our head, or repeat the translation, or write translation down so she can read and understand it herself. That's not a good analogy. Well, okay, well, maybe it is. Okay. It might sound like they're opposite now, but actually it sounds like they're quite similar. Share a lot of things in their constructions. They have a front end that reads in source code, written in source language, and turns into data structure. Both compiler and that one. Frontend is usually made up, the lexer and a parser. That's what we've done so far. So here in the front part, they have a lot of similarities. That's when they both traverse the AST and then they do different things. Since we've already built part of an interpreter, we know that it does what it does when traversing the AST. It evaluates it. The interpreter does, yes. That is, it executes instructions encoded in the tree. If a node in the tree represents source language's statement puts, then the interpreter would print hello world when evaluating the node. Compiler, on the other hand, wouldn't print anything. Instead, it would generate code in another language. Bytecode. The source code will contain target language just equivalent of the source language's puts. The resulting code would then be executed by the compiler and hello world appears on the screen. That makes sense. This is where things get really interesting, in which I read it weird. In which target language does the compiler generate source code? Which one? Which language does the computer understand? And how does the compiler do this? As text or binary? In file or in memory? But much more importantly, what exactly, I'm guessing file, because you always have a binary at the end. And more importantly, what exactly does it generate in this target language? Bytecode, I guess. What if the target language doesn't have an equivalent of puts? What should compiler generate instead? Generally speaking, we have the same answer to every one of these questions. Software development's number one answer. The only hard capital T truth in programming. It depends. I guess it does. Well, there was quite the build-up, Thorsten, I have to say, for it depends. The answer to these questions depend on many variables, the architecture, blah, 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 target language, how the output is going to be used. Is it executed directly, compiled, etc., etc. How fast it needs to run, how big the code can be, how much memory is allowed to use, and how. Okay, the variety between compilers is so high that we can't make a lot of universal statements about their architecture. Excuse me. That being said, we can ignore details for a minute and sketch out the architecture. Okay. Got source code written in a language. The lexer and parser traverse the source code. Lexer produces tokens and the parser produces statements, which statements in the form of a tree. So we get NAST. I don't know what an optimizer does. It produces internal representation. And then we have a code generator that produces machine code. Okay. Component called the optimizer. I did see it when I saw it here. It's the project name. Optimizer. Yeah. Modern source target independent optimizer along with code generation support. Okay. Might translate the AST into another internal representation. This might be another syntax tree, or maybe a binary, or even text. The reason for this translation are manifold, but the major one is that the IR, internal representation, might lend itself better to optimizations and translation into target language than the AST would. Okay. So it depends on the next step, I guess. This new IR then goes through the optimizer phase. That code is eliminated. Simple arithmetic is pre-calculated, and code that doesn't need to be there is taken out. Ton of, yeah, guess like stuff like inlining code. Okay, well, I'm running on fumes here. Alright, I'll stay till 7. This is how the simplest compilers work. And even here, 1,000 variations are possible. For example, the optimizer could do multiple passes. Over the IR. Yeah, I have heard of this multiple passes thing. Yeah. Does a different thing in each pass. What was IR again? Internal representation. Yeah. Maybe it doesn't have any another IR besides the AST. Maybe it doesn't output machine code, but assembly language or another high-level language. Whoa, I read that. Weird. Okay, maybe it doesn't do it on the IR, but on the target language. Maybe on the AST, or maybe on both. Maybe it doesn't have another IR. Okay. It all depends on the use case. Okay, fair enough. And then again, compiler doesn't even have to be a tool you run on the command line that reads and outputs a code. It can just be a single function that takes an AST, turns a string. Okay, yeah. Fundamental idea of translation: compilers take in source code in one and produce another. The rest depends on what you need it for. What the target language is capable of, and by which machine it can be executed, shapes the design of a compiler like nothing else. Now, what if we didn't have to choose a target language, but could invent our own? What if we didn't have to leave it at that and dream up the machine that executes this language? Okay. Oh, I guess that's a good segue to virtual and real machines. Guess that's where I'm gonna stop. Cause I get some of it, but now I'm starting to lose comprehension. There's quite a bit of reading, quite a lot. Okay, this is just an example. Oh, interesting. It looks pretty cool though. Can't wait. Okay, there is the next few days is only going to be reading. So it seems. Okay, I guess that's what I'm gonna call it a day. It's not very exciting, but I guess it needs to be done because I have no idea what I'm doing. I have to read it through. And if you're still here, thank you for hanging out. And I shall see you tomorrow. Oh, didn't realize my stream froze. Hopefully it hasn't been like that for a while. Okay, I think it's fine. All right, anyway, thank you and have a good one. I shall see you tomorrow. Bye.